Welcome to the deep dive. We're really thrilled you're here with us today because we are looking at something that feels like an absolute tectonic shift in the professional landscape.
Yeah, it really does.
Right. Like, you know that feeling when the underlying infrastructure of an entire industry just changes overnight and suddenly everyone is scrambling to figure out where the new leverage lies.
Absolutely.
That is the specific moment we are in with artificial intelligence right now. So today's mission is to critically examine this framework we pulled from a stack of recent economic research and industry analyses. And it details the 10 AI skills projected to be worth millions in career capital by 2030.
Millions.
It's a staggering projection.
It is. And we are going way beyond the basic, how to use a chatbot discourse here. We are talking about deep structural changes and how value is actually created.
Right. And it's a profound transition we're mapping out today for you. Based on the materials we're examining, we aren't just looking at a speculative list of tech buzzwords. We are analyzing a fundamental macroeconomic decoupling. Decoupling, I like that word for this.
Yeah, because historically, an individual's economic value was highly correlated with the volume of routine tasks they could execute.
Just grinding out the work.
Exactly. Now, we are seeing the rapid transition from routine task execution to highly specialized, high-value orchestration. The goal today is to strategically analyze how the entire professional landscape is reorganizing itself around these new capabilities. So whether you are leading an enterprise engineering team, building a startup, or just analyzing market trends.
Or even just starting your career.
Right. Understanding this shift is critical for your immediate trajectory.
And what's interesting is the tone of the research is surprisingly empowering. Despite the broader public anxiety about automation right now, it doesn't read like a post-mortem for human labor. It reads like an architectural blueprint.
That's a great way to put it.
The central premise jumping out of our source material is the absolute end of routine. But I want to push past the obvious stuff. I mean, we already know that basic data entry or boilerplate email drafting is automated. What fascinates me is how deeply this automation is penetrating tasks we previously considered, true knowledge work. We were looking at complex legal discovery, mid-level financial auditing, standard code generation, all just being eaten by these models.
And that is the core of the macroeconomic decoupling I just mentioned. When the marginal cost of intelligence, or at least highly convincing pattern recognition, drops to near zero.
Which it basically has.
Exactly. The market stops paying a premium for the physical or digital labor of generating that pattern. The premium shifts entirely to the oversight, the direction, and the strategic deployment of that intelligence.
Right.
Think about the concept of the Jevons paradox in economics. As a resource becomes more efficiently utilized, its overall consumption actually increases.
Oh, like when we made cars more fuel efficient, people just drove more.
Precisely. So as cognitive labor becomes cheaper via AI, businesses aren't going to stop thinking. They're going to demand a massively increased volume of cognitive output.
So it's not that we need fewer analysts. It's that the baseline expectation for an analyst goes from generating one quarterly report to simulating, 10,000 market scenarios an hour.
That captures the dynamic perfectly. The physical labor of assembling the report is essentially free now. The market places an unprecedented premium on the person who knows exactly which parameters to set for those 10,000 simulations.
Yeah, making sense of the noise.
Right, how to interpret the probabilistic output and how to integrate those findings into a broader corporate strategy. The AI era does not signify the evaporation of jobs. It signifies a fundamental reorganization of what a job actually is. You're transitioning from an executor to a manager of non-deterministic systems.
Which requires a completely new toolkit. And the research breaks this toolkit down into 10 distinct skills, starting with a foundational layer that essentially acts as the new baseline for operating in this economy.
The absolute prerequisite.
Exactly. So the first skill on this list is AI literacy. Now, for you listening, we aren't talking about knowing how to log into Claude or ChatGPT. We are talking about a much deeper structural understanding of the technology. How do the sources define literacy for a professional who is, say, already heavily using these tools?
Well, in this advanced context, AI literacy is the strategic ability to understand the underlying architecture and the limitations of probabilistic models.
Okay, break that down. Probabilistic.
It's understanding that a large language model is not a database of facts. It's an engine of statistical probability predicting the next most likely token. A truly literate professional understands the difference between deterministic software, where a specific input always yields the exact same output, and these probabilistic systems, which introduce variance.
They can surprise you.
Right. They understand concepts like retrieval augmented generation, or RAG, and why pointing an LLM at a proprietary vector database actually reduces hallucination.
I'm really glad you brought up RAG and hallucination, because a major part of this literacy seems to be an acute awareness of failure modes.
Yes.
It's so easy to trust an output when it looks highly confident. But true literacy is knowing where the model is likely to degrade. For instance, understanding how a model behaves when it reaches the limit of its context window, or knowing that it might struggle with complex spatial reasoning, even if its linguistic reasoning is absolutely flawless.
And that failure mode awareness is crucial at the enterprise level. If an engineering leader is deciding whether to implement an LLM to automate a customer service pipeline, their AI literacy dictates the architecture. They know that they cannot just hook an API directly to a customer-facing portal without deterministic guardrails.
Because it might just offer a customer a car for $1.
Exactly. We've seen that happen. They understand latency constraints, the cost-to-compute ratios of different model weights, and the strategic difference between relying on a massive proprietary model versus fine-tuning a smaller open-source model for a highly specific edge case. That is what literacy looks like at the high-value end of the spectrum.
And once you possess that deep architectural understanding, you have to actually interface with these systems. Which brings us to the second foundational skill: prompt engineering.
A very hot topic.
Very. There is a vocal debate in the tech community right now. A lot of people argue that prompt engineering is just a transitional skill, that as the models get smarter and better at inferring our intent, the need to carefully engineer prompts will just disappear. But this framework insists it will be one of the most lucrative skills of the decade. Why the discrepancy there?
The discrepancy comes from a complete misunderstanding of what advanced prompt engineering actually entails. The critics are right if you define prompt engineering as simply adding please and thank you, or basic role-playing instructions to a chat interface.
Act as an expert marketer.
Right, exactly. Yes, the models will get better at zero-shot inference for simple queries like that. But at the enterprise level, prompt engineering is essentially a new programming paradigm using natural language. It is about constructing complex, multi-step system prompts that govern autonomous agents.
So we are moving away from single-turn conversations into complex reasoning frameworks. I'm looking at concepts in the research like chain-of-thought prompting or a tree-of-thought architectures. You aren't just asking a question. You are forcing the model to explicitly map out its logical steps before generating a final answer.
Which drastically reduces error rates in complex problem solving.
Exactly.
Consider the mechanics of optimizing a context window. Let's say you're feeding an LLM a 2 million token context, perhaps an entire repository of legacy code, or 10 years of financial disclosures. An amateur simply dumps the data and asks a question.
And hopes for the best.
Right. An advanced prompt engineer understands the needle in a haystack problem. They know that models often suffer from attention degradation when they just forget information located in the middle of a massive prompt.
They only remember the very beginning and the very end.
Precisely. Therefore, they engineer the prompt to force the model to recursively summarize segments, extract key vectors, and weigh certain documents higher than others before it ever attempts to synthesize an answer.
It's fascinating because you are essentially managing the cognitive load of a machine. You are structuring the constraints so tightly that the probabilistic output is forced into a highly deterministic, reliable format.
That's the perfect way to phrase it.
And that leads directly into the third foundational skill, which is perhaps the most disruptive to a traditional industry: AI-assisted coding. I remember when GitHub Copilot first rolled out, it was a neat autocomplete tool. Now, we are looking at agentic coding environments where the AI is scaffolding entire applications.
The transition from autocomplete to agentic orchestration is a complete paradigm shift for software engineering. Historically, software development was bottlenecked by syntax. Engineers spend an exorbitant amount of time writing boilerplate code, managing microdependencies, and hunting down minor syntax errors.
Missing semicolons.
Exactly. AI-assisted coding at the highest level shifts the human role entirely, from writing syntax to system architecture and code review.
I was reading an analysis on how this is changing the architecture itself. For a long time, the industry standard was breaking applications down into microservices, partly because it was easier for human teams to manage and update isolated chunks of code.
Yes, to reduce cognitive overhead for the human developers.
Right. But with LLMs capable of holding massive monolithic code bases, in their context windows and understanding the intricate dependencies across the whole system, are we seeing a shift back toward LLM-orchestrated monoliths?
That is a very real architectural debate happening right now. When an AI can instantly refactor a monolith without the human cognitive overhead that traditionally made monoliths so brittle, the strategic calculus changes entirely. But the core skill here isn't just letting the AI write code.
What is it then?
It is the rigorous ability to evaluate what the AI has written. Because AI models are trained on historical data, they can sometimes propagate outdated security vulnerabilities or implement inefficient sorting algorithms. The high-value skill is being the senior architect who can review AI-generated pull requests, spot the non-deterministic edge cases, and ensure the system is secure and scalable.
It also completely democratizes internal tooling. Think about it. If an operations manager needs a custom script to automate a data pipeline between two obscure SaaS products, they no longer have to wait 6 months for the internal engineering team to prioritize it in a sprint.
Yeah, they don't.
They can use AI-assisted coding to build a secure, functional script themselves over a weekend.
That democratization of tooling is a massive force multiplier for a business. But again, it requires that foundational literacy we talked about. The operations manager still needs to understand API rate limits, data encryption standards, and version control. The AI writes the language, but the human must still govern the logic and the security.
So we have our foundational triad: AI literacy, advanced prompt engineering, and AI-assisted coding. That is the baseline required just to play the game.
The new entry stakes.
Yeah. But the framework really gets interesting when we look at how these foundational skills intersect with specific industry domains. This brings us to the specialization phase, starting with skill number 4, AI data analysis. We produce more data now than at any point in human history, but gathering, it used to be the primary bottleneck. Now that gathering is automated, how does the skill of analysis evolve?
The evolution is moving from descriptive analytics to prescriptive, highly automated pipelines. A traditional data analyst would spend weeks cleaning a data set, resolving null values, standardizing formats, and writing SQL queries just to build a dashboard that shows what happened last quarter.
Which is purely descriptive.
Entirely descriptive. In the high-value AI economy, the data analysis skill involves orchestrating multimodal data ingestion. You are feeding unstructured data like raw customer support audio files, PDF contracts, and real-time market sentiment on social media into an LLM pipeline that structures the data on the fly.
That is a huge leap. Dealing with unstructured data used to be an absolute nightmare for analysts. You're saying the analyst now builds a system where the AI acts as a translation layer, turning messy, real-world noise into structured vectors that can be queried instantly.
Precisely. And once the data is structured, the analyst isn't writing queries to find out what happened. They're building agentic loops that constantly monitor the data to predict what will happen next and prescribing an action based on that.
Give me an example of that in the real world.
Well, in a massive enterprise environment, you don't just want an alert that supply chain costs are rising. You want an AI data analyst to build a system that identifies the rising cost, cross-references it with global weather patterns and geopolitical news, simulates 3 alternative shipping routes, and presents the most cost-effective recommendation to the executive team in real time.
That's incredible. But how do you deal with the risk of data pipeline hallucination? If the entire pipeline from unstructured data to executive recommendation is automated via LLMs, what happens when the model hallucinates a correlation that just doesn't exist? A slight temperature variation in the model's output could lead to a multi-million-dollar supply chain error.
That is exactly why this skill is valued in the millions. The amateur trusts the output implicitly. The advanced AI data analyst builds self-correcting data loops.
Self-correcting loops.
Yes. They implement deterministic verification steps within the probabilistic pipeline. They might have a smaller, highly fine-tuned model specifically trained to act as a skeptic.
Oh, a skeptic model.
Right. It aggressively challenges the assumptions and correlations generated by the primary analytical model before any recommendation is passed to a human. The skill is architecting the system of checks and balances within the data flow.
I love that concept, deploying a skeptical model to audit the analytical model. It is adversarial design.
Exactly.
Let's pivot that design mindset over to the user-facing side. Skill number 5 is AI product design. And I think this is one of the most misunderstood areas right now. Slapping a generic chat interface on top of an existing software product seems to be the default move for a lot of companies. But the framework suggests true AI product design is far more radical.
Adding a chat window to a legacy dashboard is the equivalent of putting a motorized engine on a horse buggy.
Right.
It completely misses the structural advantages of the new technology. True AI product design is a shift from deterministic user interfaces to probabilistic generative user interfaces.
Okay, let's drill down into generative UI. Because traditionally, a designer uses a tool like Figma to build distinct, static screens. If the user clicks this button, load screen B. It's a hard-coded journey. How does generative UI break that mold?
In a generative UI paradigm, the interface itself is fluid and does not exist until the user expresses an intent. Instead of forcing a user to navigate through a complex hierarchy of menus to accomplish a task, the product designer architects a latent space.
The latent space.
Yes. When a user inputs a prompt, perhaps saying, compare our Q3 marketing spend against our competitor's estimated ad buy, the AI doesn't just return text. It generates a bespoke, fully functional interactive dashboard on the fly, complete with custom charts, sliders, and data tables specifically tailored to that single query.
Wow.
And once the user is done, that specific interface dissolves.
That is incredibly powerful, but it sounds like a nightmare for brand consistency and user trust. If the interface is hallucinated into existence differently every single time, how does a user ever feel grounded? How do you maintain a cohesive product experience if the navigation keeps shapeshifting?
That is the defining challenge for the AI product designer. They have to transition from designing static pixels to designing behavioral boundaries. You have to anchor the generative UI in strict brand guidelines, component libraries, and structural logic.
So the AI can't just invent a new font or color scheme.
Exactly. The AI is only allowed to assemble the interface using pre-approved, highly tested, accessible components. The skill is designing the guardrails, the feedback loops, and the intuitive affordances that make a highly unpredictable system feel totally predictable, safe, and helpful to the end user. You are designing for latency, managing user expectations while the system thinks, and ensuring graceful degradation if the AI fails to generate a useful interface.
It's almost like designing the psychology of the product rather than just the visuals.
That's exactly what it is.
And that reliance on deep system architecture segues perfectly into skill number 6. Automation engineering. This goes beyond just writing a quick script. The sources describe this as building the plumbing of the new economy. We are talking about connecting disparate AI agents together to form invisible, continuous workflows.
The modern enterprise relies on dozens, sometimes hundreds, of different software applications. Automation engineering is the discipline of making those systems talk to each other autonomously. And with the introduction of multi-agent frameworks like LangChain, AutoGen, or Crew AI, we are no longer just passing static data from point A to point B. We are passing complex cognitive tasks between specialized AI agents.
Give me a breakdown of what a multi-agent workflow actually looks like in practice. How does this differ from traditional robotic process automation, or RPA?
Traditional RPA was incredibly brittle. It relied on screen scraping or highly specific API calls. If an external website changed its layout by a few pixels, the entire RPA bot would just break.
Right, it had no actual understanding of what it was doing.
None. Multi-agent automation engineering is resilient because it is semantic. Let's look at a complex B2B sales pipeline. An automation engineer builds a system where an OSINT agent constantly scans the internet for news about target companies. When it detects a trigger event, say a target company announces a new round of funding, it passes that semantic context to a research agent.
Okay, so a handoff.
Yes. The research agent deep dives into the company's tech stack, identifies key decision makers, and summarizes their recent public statements.
And then it passes that enriched profile to a copywriting agent to draft a hyper-personalized outreach email.
Yes, but with crucial intermediate steps. It passes the draft to a compliance agent that ensures the email doesn't violate any regulatory guidelines or make unsubstantiated claims. Then it passes it to a strategy agent that reviews the draft against the historical success rates of previous campaigns.
So they're cross-checking each other.
Exactly. Only after all those agents have debated and refined the output does the system present a final draft to a human sales executive for one-click approval. The automation engineer is the person who builds, monitors, and optimizes that entire multi-agent ecosystem.
The complexity of managing error handling in a loop like that must be staggering. If one agent misinterprets a signal, it could cascade through the whole system. The skill of the engineer is building the fail-safes, the logging, and the human-in-the-loop triggers to prevent a runaway process.
Yes, that's the multi-million-dollar skill.
And when you apply that level of hyperscale automation to outbound communication, you arrive at skill number 7, AI marketing strategy. This feels like an area that is just being entirely rewritten from the ground up.
Marketing is undergoing a seismic shift. For the last decade, digital marketing was dominated by broad demographic targeting and A/B testing. You created ad variation A and ad variation B, ran them for a week, and scaled the winner. It was a highly manual, relatively slow feedback loop.
Yeah, that's how everyone learned to do it.
But AI marketing strategy replaces A/B testing with infinite, real-time generative testing driven by multi-agent reinforcement learning.
So we're moving past demographics entirely. I was reading about how these models match real-time behavioral vectors. It's not about targeting males aged 25 to 34 who like sports anymore.
No, not at all.
It's about an AI system identifying a specific user's microbehavior across the web in the last 20 minutes and generating an entirely unique piece of creative media specifically for them at the exact moment they are most likely to convert.
The hyper-personalization at the edge is phenomenal. An AI marketing strategist is operating a system that dynamically generates the ad copy, the imagery, the video components, and the call to action on a per-impression basis. It is running thousands of micro-variations simultaneously. It automatically routes budget toward the variations achieving the lowest customer acquisition cost, minute by minute, across multiple platforms. The role of the human marketer completely detaches from copywriting or media buying.
But wait, if the AI is generating all the copy and optimizing all the spend, what is the actual high-value skill left to the human strategist? Don't you run the risk of massive brand dilution?
How do you mean?
Well, if the AI figures out that highly sensationalist off-brand copy gets the highest click-through rate, it will optimize for that, potentially destroying a brand's reputation for a short-term spike in metrics.
That is the exact trap amateur marketers fall into with these tools. The advanced AI marketing strategist manages the objective function. Their skill is fine-tuning the models on the brand's proprietary vectors, the historical voice, the core values, the visual identity.
They align the AI with the brand's soul, essentially.
Exactly. They implement internal reinforcement learning from human feedback, or RLHF. They teach the AI the nuanced difference between a high-performing ad that aligns with the brand and a high-performing ad that just feels like spam. They design the algorithmic guardrails to ensure that as the personalization scales to millions of users, the core integrity of the brand remains impenetrable.
It requires a deeply analytical mind to manage the creative output of a machine. And when you combine that marketing leverage with the automation engineering, the product design, and the coding, you arrive at an entirely new category of business formation. This is section 4 of the framework, which deals with leadership and macro strategy, starting with skill number 8. AI entrepreneurship. The concept of zero marginal cost execution. I am totally fascinated by this. We are looking at a future of solopreneurs scaling companies that would have historically required 100 employees.
The leverage available to a single founder today is historically unprecedented. In previous eras, the bottleneck to building a massive enterprise was execution. You might possess a brilliant strategic vision, but executing that vision required raising millions of dollars in venture capital to hire a sprawling team of engineers, copywriters, HR professionals, and legal counsel. AI drives the cost of execution down to near zero.
I was looking at the tech stack of some of these new hyperlean startups. A single founder uses an LLM to conduct comprehensive market research and identify a gap. They use agentic coding frameworks to build the minimum viable product over a few weeks. They deploy multi-agent marketing pipelines to launch it. And they use highly tuned customer service agents integrated with their documentation to handle user support.
It's incredible.
The founder is acting as a conductor of an orchestra, but every single musician is an AI agent.
And because their overhead is practically non-existent, their profit margins are astronomical, and their ability to pivot based on market feedback is instantaneous. They don't have to align 100 employees to change product direction. They just have to update the system prompts across their agentic infrastructure. The core skill of AI entrepreneurship is resource allocation and orchestration. It is the ability to break down a massive commercial goal into discrete, programmable tasks that can be delegated to specialized models while managing the API costs and ensuring the disparate systems remain integrated.
It sounds like an absolute utopia for builders and creators. But, and this is where the framework takes a very serious turn, managing an interconnected web of autonomous agents operating at high velocity introduces massive systemic risk. Which brings us to the final 2 skills on our list, and the central tension of this entire deep dive. We have skill number 9, AI ethics and governance. And we have skill number 10, human creativity amplified by AI.
The sources present these final two skills as the ultimate divergence point for high-level professionals. Both are projected to be phenomenally lucrative, but they represent entirely different philosophies on what will drive the most value in a saturated AI economy. The tension between them is profound.
I really want to debate this because I have very strong convictions here. I will plant my flag firmly on the side of skill number 10, human creativity amplified by AI. I argue that the ultimate competitive advantage, the true source of multi-million-dollar value by 2030, is human intuition, lateral thinking, and the emotional resonance that only a human can provide.
I understand the appeal of that position, but taking a cold analytical look at the corporate landscape, I have to argue for skill number 9, AI ethics and governance. I believe the ability to navigate risk will outprice the ability to generate novelty. Make your case for creativity. Why does it win?
Because when every single company on Earth has access to the exact same frontier models, the exact same coding agents, and the exact same data analysis pipeline's baseline execution becomes a commodity.
Okay, that's true.
The ability to write a flawless piece of software or a perfectly optimized ad campaign won't be special. It will be the bare minimum required to even exist. The only true differentiator left in a commoditized market is the human spark. It is the ability to navigate the latent space of these models and find intersections of ideas that a purely probabilistic system would never prioritize. AI can iterate on what exists, but human imagination is required to conceptualize what doesn't.
I can see that differentiation is vital. But consider the operational reality of scaling those creative ideas. Creativity without rigorous systemic constraints in an AI-driven world is a massive existential liability. I argue that AI ethics and governance is a superior skill because it is the ultimate bottleneck for enterprise deployment. As these systems become more autonomous, the risk of catastrophic failure scales exponentially.
But you can't regulate your way to a breakthrough product. Governance is inherently defensive. It's about slowing things down. The companies that capture the market are the ones that move fast, leverage human creative vision, and use AI as a massive amplifier for their unique perspective. The emotional connection a human creator builds with an audience cannot be generated by a compliance algorithm.
That is a common assumption, but looking at the data, the penalties for moving fast and breaking things in the AI era are fatal. If a company's hyper-creative, multi-agent marketing system hallucinates factual errors about a competitor, or inadvertently ingests and reproduces copyrighted material from a proprietary database, or relies on biased data that systematically discriminates in pricing,
Those are bad outcomes, sure.
they aren't just bad outcomes. That company doesn't just face a PR crisis. Under incoming regulatory frameworks like the EU's AI Act or massive data privacy laws globally, that company gets hit with staggering fines and faces injunctions that shut down their models entirely.
I hear the risk, but keeping the company out of court doesn't generate revenue.
Yeah.
It just stops you from losing it. The creators, the visionaries who know how to prompt the models to write a script or design a product that actually moves people, they are the revenue generators. They are the ones defining the culture.
But the revenue generators cannot deploy their work without the governance architect. Understanding algorithmic transparency, data provenance, and bias mitigation is not just for lawyers anymore. It is a highly technical skill. An AI governance expert has to look at the complex black box architecture of a neural network and design interpretability layers.
Interpretability layers.
Yes. They have to prove to regulators exactly how the AI arrived at a specific decision. They have to build the deterministic circuit breakers that prevent an autonomous trading bot from causing a flash crash, or prevent a customer service agent from executing unauthorized refunds. The person who architects the safety systems that allow the enterprise to utilize AI at scale without facing catastrophic legal liability is the most scarce and therefore the most valuable asset in the boardroom.
Okay, I have to admit, the point about interpretability layers is strong. If you can't explain why your brilliant creative AI system did what it did, you can't legally deploy it in a high-stakes environment like healthcare or finance. So the creativity is bottlenecked by the governance. But on the flip side, perfect governance of a boring, uninspired product still results in a company that fails to attract customers.
Which brings us to the synthesis of the debate. The research indicates that these are not mutually exclusive career paths, but rather the two most critical poles of the new economy. The tension between boundary-pushing human creativity and rigorous systemic governance is exactly what produces sustainable, high-value progress. A professional must choose which side of that fulcrum they want to master, or figure out how to bridge the gap between them.
It is a phenomenal strategic choice to consider. Are you the visionary pushing the models into uncharted territory, Or are you the architect building the containment structures that make that exploration safe? And that leads us to the most practical part of our deep dive. Theory and macroeconomic debate are great, but how does a listener actually acquire these skills? How do you move from understanding this framework to actively building that career capital?
The sources outline a very specific three-pillared action plan for skill acquisition, and it begins with structured, formal learning, specifically high-level online courses.
Now, let's be clear. For our audience, we aren't talking about introductory "what is AI" webinars. We are talking about deep technical immersions.
Absolutely. The value of an advanced online course is building a rigorous mental model of the underlying mathematics and architecture. If you are going to manage multi-agent frameworks or design interpretability layers for governance, you cannot rely on surface-level intuition. You need to take courses that explain transformer architecture, the math behind attention mechanisms, the intricacies of vector embeddings, and the methodologies for fine-tuning open-source models. Structured learning gives you the precise vocabulary and the theoretical map required to navigate complex implementations.
But a theoretical map is useless if you never step into the territory.
Yeah.
Which brings us to the second pillar, daily immersion with the tools. And I really want to stress how critical this is. You cannot intellectualize your way to AI mastery. The models act in ways that are deeply counterintuitive until you experience them firsthand.
The friction of daily use is where intuition is forged. It is about hitting the API limits. It is about writing a complex prompt, watching the model completely fail to follow instructions, and then painstakingly reverse engineering the prompt to understand why it failed. It is testing the boundary between a model's linguistic capabilities and its logical reasoning constraints.
And observing the subtle differences between models. Recognizing that Claude might handle a specific coding architectural question better than GPT-4, or that a specialized local model is required for a highly sensitive data task. That intuition only comes from constant, daily friction. And that friction prepares you for the third and unquestionably the most important pillar, hands-on projects.
Structured learning provides the theory. Daily immersion provides the intuition, but hands-on projects provide the mastery. The only way to prove you possess these high-value skills is to architect a solution to a real-world bottleneck.
What does a high-value project look like for someone trying to transition into this space? How do they avoid getting stuck in what developers call tutorial hell, where they just follow along with YouTube videos but never actually build anything novel?
You avoid tutorial hell by identifying a highly specific, painful bottleneck in your current industry or your own workflow, and building an end-to-end AI system to solve it. Do not just build another generic chatbot. If you work in logistics, use your theoretical knowledge and your tool intuition to build a local RRAC pipeline that ingests messy vendor contracts and automatically flags compliance anomalies. If you are a designer, build a generative UI prototype that adapts its layout based on real-time user engagement metrics.
It has to be proprietary. It has to be something that forces you to deal with unstructured data, complex API integrations, and non-deterministic error handling. When you build a system that breaks 10 times and you have to dig into the logs to fix the hallucinations or the multi-agent cascade failures, that is where you forge the career capital. You emerge from that project not as someone who uses AI, but as someone who orchestrates it.
And that orchestration is exactly what defines the future of work. Let's look at the macro picture based on everything we've analyzed. As we move toward 2030, we are entering the managerial era of work for the individual.
The managerial era. Because the execution is entirely decoupled from the human. Your job is no longer to be the individual contributor pounding on the keyboard. Your job is to be the executive of your own automated infrastructure. Even an entry-level professional will be expected to manage a fleet of specialized AI agents, verify their accuracy, enforce governance, and strategically apply their output to the business's goals.
You are auditing, editing, and directing. And we must return to the staggering projection we started with. Mastering these 10 concepts could generate millions in economic value. When you fully internalize the leverage we've discussed today, when one highly skilled individual equipped with advanced prompt engineering, agentic coding, and multi-agent marketing can output the work of an entire traditional department, their premium in the market becomes effectively uncapped.
It is a massive reorganization of leverage. We've covered a tremendous amount of ground today. We started by examining the macroeconomic shift away from routine task execution. We broke down the foundational triangle, the architectural depth of AI literacy, the systemic logic of prompt engineering, and the paradigm shift of AI-assisted coding. We look at how those foundations apply to orchestrating data pipelines, designing probabilistic products, engineering invisible automation, and personalizing marketing at the edge.
We analyzed the zero marginal cost execution of AI entrepreneurship, and we engaged in the critical structural debate between scaling human creativity and enforcing rigorous AI ethics and governance. Finally, we mapped out the path to acquisition through deep theoretical study, relentless daily immersion, and the construction of complex, real-world projects.
It is an incredible roadmap for navigating the next decade. But as we wrap up this deep dive, we want to bring the focus entirely back to you, the listener.
We have analyzed the market, the technology, and the strategic leverage. But the ultimate variable in this equation is your own trajectory. Look closely at the framework of these 10 skills. Where does your existing expertise intersect with this technological shift? Which of these domains will you commit to mastering, and which of these 10 skills will ultimately define your professional future by 2030?
A profound question to leave you with. Thank you for joining us for this deep dive into the architecture of the new economy. Start building, keep experimenting, and we will catch you next time.